So we are still working on the Unit 2 review chart, but finally made it to the last page and the last video. So what we're going to review now is scientific notation, still using exponents. So this was a big chapter or unit for us in math and leading into Algebra 1. So scientific notation, truthfully, it's a way to write really, really long numbers. Not necessarily large or small, because they could be either, but it just allows you to write large numbers, especially when you're looking at something in a calculator, because often you will, and this is going to be later on, probably more science, but you might work out a problem in a calculator and you end up with an answer in scientific notation. Well, that's just because there aren't enough space, digit space, on the calculator to show the full number. So again, if you need to pause the video to get all the information, then please do. So this is the format of scientific notation. So the value of A is going to be that leading number. This needs to be between 1 and 10. So this number right here has to be a number between 1 and 10. Now, I say between 1 and 10, but it actually can't be 10 because it has to be less. You could turn 10 into a 1, whatever. We can do that to any number by moving the decimal. So that's why this is over here, because multiplying or dividing by 10 is what allows us to move a decimal. All right? If the exponent right here is positive, that means that our number is very large. And that positive number will tell you how many places you need to move your exponent. If this value right here is negative, then that means that the true value of the number is very small. So you would have to move that number of places, your decimal, that number of places to make the number small. All right, so let's just start with 3.2 times 10 to the 6th. All right, so first up, this is in scientific notation. This is between 1 and 10. This tells us to move the decimal 6 places. Since it's positive, we need to make 3.2 6 places bigger. So that means we're going to move it to the right. So if we put this, we start with 3. There's 1 place, 2, 3, 4, 5, 6. So 3.2 times 10 to the 6th is 3,200,000. All right, let's say that I gave you 7.1 times 10 to the negative 3rd. All right, so this is scientific notation because this is between 1 and 10. This is telling us to move the decimal 3 places, but we need to move it so that 7.1 becomes smaller. So in order to make 7.1 smaller, I would need to move the decimal this way. So I need to move the decimal 3 places this way. So if you think about that, that's going to mean 0,071. All right, let's go the opposite direction. So let's say that I gave you 12,376,000. All right, so first thing is we have to get this number to be a number between 1 and 10. So I know you can't respond to me, but do we move it here? No. Here? No, 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 no. Right here. This is where the decimal has to go in order for this to become a number between 1 and 10. So our number is going to be 1.2376. So now what we need to do is identify how many places did we move that decimal. So there's 1, 2, 3, 4, 5, 6, 7 places. All right, so now we need to think about it. If I'm going from here to here, do I need to make this 7 places bigger, or do I need to make this number 7 places smaller? Well, the answer is I need to make this 7 places bigger, so this should be a positive 7. All right, you can have negative numbers, doesn't matter. So let's say we had negative 0.00045. All right, I need to make this decimal into a number between 1 and 10. So that means that I need to put the decimal right here. So this is no longer going to be negative 0.00045. It's now going to be negative 4.5. So the negative just follows along. All right, so now I need to identify how many places to move the decimal. Well, if I'm using this number to get to this number, I need to make it smaller, so I need a negative. And 1, 2, 3, 4 decimals. So if I start with this number, I need to move the decimal 4 places to make it smaller. So that's a quick review of just writing numbers in scientific notation. So now what we're going to look at are the operations with scientific notation. So this is going to involve the exponent rules that we did on the previous page. And again, if you need to pause the video to get all of the information recorded, then do. All right, if we're multiplying, we're going to add the exponents, just like we did before. If we're dividing, we subtract the exponents, just like we did before. Adding and subtracting is going to be a little different. So let's do an example of multiplying and dividing first, and then we'll come back to the adding and subtracting. So let's say we were going to multiply 3.1 times 10 to the 6th, and let's multiply that with 7 times 10 to the negative 3rd. All right, so what we need to do here is multiply 3.1 times 7. So when we multiply 3.1 times 7, that is going to give us 21.7. 7 times 1 is 7. 7 times 3 is 21. All right, now since we're multiplying, we add exponents together. So the exponent on our 10 is now going to be a positive 3. All right, so now we need to look at our answer. Is this answer in scientific notation? No, because this is not a number between 1 and 10. So here's the way it works. I need to make this from 21.7 into 2.17. So since I made this number smaller, one place, I need to make this exponent bigger, because the exponents and the decimals move together. So this one went smaller, means that one has to go bigger. So now this is an answer that is in correct scientific notation form. All right, let's try dividing. Let's say we had 8.1 times 10 to the 5th, and we're dividing by 0.3 times 10 to the negative 2nd. So, first thing we need to do is just take care of dividing our numbers. So this is 8.1 divided by 3, which is basically 81 divided by 3. So 81 divided by 3 is 27, so that means 8.1 divided by 3. So if you follow that, if we move the decimal, we just have 81 divided by 3. So that gives us 27. All right, now, since we're dividing, we need to subtract the exponent. So remember, 5 minus negative 2 means 5 plus 2, which means to the 7th. So now we just need to evaluate if this is truly in scientific notation. And again, it's not. This is not a number between 1 and 10. So I need to rewrite this as 2.7. So since I made 27 smaller to get 2.7, I need to make my exponent bigger. So now I have an answer that's in the correct scientific notation form. Okay, adding and subtracting. The deal with adding and subtracting, if you think about math, every time you add and subtract, something has to be the same. You have to have a common denominator. You have to line up the decimals. You have to have like terms. Anytime we add and subtract, it has to be the same. So what's going to happen here is in order to add and subtract, you have to have the same exponent. So let's say that we had 7, I feel like I keep using all the same numbers. That's because I am. 7.2 times 10 to the 4th. And let's add that with 2 times 10 to the 6th. Okay, what we need to do is we need to get these exponents to be the same. So if we were adding fractions, we'd get the denominators to be the same. So same idea, just different process, because we need to get the exponents to be the same. I always go to the larger exponent. So most of the time, that will prevent you from having to change your answer like we had to do up here. Maybe not always, but I'm going to go ahead and change this one. So what's happening here is I'm going to keep this as 2 times 10 to the 6th. But what I need to do down here is I need to change this to be 10 to the 6th. So let's think about just like what we did up here. Since I made the exponent 2 larger, I have to move the decimal 2 smaller. So moving the decimal 2 smaller is going to be 0.072. So now I have the same exponent, so I can add them together. So 2 added to 0.072 is going to be 2.072 times 10 to the 6th. So just like in fractions also, once you get the same denominator, you don't add denominators, you keep it. So once we get the exponents to be the same, we keep them. All right, that covers exponents, that covers scientific notation. You might want to watch that again. I remember in years past that there was quite a lot of scientific notation on the milestones test, so you might want to just review that, make sure you have that one covered. All right, looking at equations. So we've done equations a couple of times. Let's say we have, let me do a different color, sorry. 6n plus 1 equals 16 plus 3n. Again, if you need to pause the video to get the information written down, please do. We have to get the variables on the same side. I usually do that first. And then we're going to undo the rest so that the variable is alone. So when I want to solve for n, that means I need to get the n by itself. First thing I need to do is get the n's together. So I'm going to subtract 3n from both sides. So it's gone over there. 6n minus 3n would be 3n plus 1 equals 16. Now we need to get everything away from the n, and we start furthest. They're the easiest to move. So I'm going to move this by subtracting 1 from both sides. So that's gone. 3n equals 15. To get this n disconnected from the 3, I need to divide by 3. Whatever you do to one side, you do the other. That cancels, and n equals 5. And any problem can be checked by filling this in. So if you go back in at the top and replace this, you will get the correct answer. All right, very quickly, I want to try and see if I can get one with distributive property worked out. If the video ends, we're just going to go with it. But let's try -9 and then c minus 4 equals -5 and c minus 4. Okay, so first thing, when we have parentheses, that means distributive property. So what we're going to do is distribute the -9. So -9c plus 36. On the right side, we're going to distribute the -5. -5c plus 20. And now this problem is just like this problem. So I need to get the c's together. So I need to get rid of a -5, which I can do with a +5. So add 5c to both sides. That cancels. So on the right side we have 20. On the left side, this is -4c plus 36. So now I need to start chipping away to get c by itself. Subtract 36 from both sides. So -4c is -16. Divide both sides by -4, and c equals 4. Again, you can check by filling that solution back in.